we have some numbers here. Let's say they are scores on a quiz. Okay, so your class gave a quiz. Maybe it was like at a 12 or something like that. Okay, these were the scores that there's only an 8-person class. This is what you got. So we want to find the average score in the class. To figure out the average score in this class, we need to sum or add up all of these values. Right? Usually they'll write that as the sum of x, okay, divided by
how many there are.
Yeah, the number of x's. Okay. In that case, there are 8 of these, so we're going to be dividing by 8, and we have to sum all these values together. I'm going to get you to follow with your calculator because sometimes I type things in wrong. So let's just double check here. I think I can do this in my head. I might actually be better in my head. So let me see. You follow with your calculator. Tell me if you get 58 when you go through this.
Yeah.
Good. Okay. So this is essentially 58 divided by 8.
7.25.
What is it?
7.25.
7.25. Great. So our x bar, or our mean, is 7.25. Now from here, what we usually do is we write our data. So we'll write the data. Yeah, in a chart form. Okay, and we usually go from lowest to highest. So it goes 3, 4, 6, 7, 8, 9, 10, 11. Pretty much in order. 3, 4, 6, 7, 8, 9, 10, 11. From here, they tell us to subtract from x bar to get a value.
Subtract the thing number.
Yeah, so we got to subtract from 7.25.
And then after you do that, you're going to
square all those values. Good. So I want you with your calculator.
And then you're going to add that all up, and then you're going to do that circle thingy.
You got it. Oh, no, it won't be a pie chart.
No, I know. The cursive O looking thingy.
Yeah, to find the standard deviation. Good. Okay, so if we were to subtract these, this becomes negative 4.25. Just double check that for me. Okay, which means this is negative 3.25.
Yeah.
So this is negative 1.25. This is negative 0.25. Positive 0.75. 1.75. 2.75 and 3.75. Okay? So that's all of those together. The next thing we have to do, I'm going to give them a new symbol, even though they usually don't. Okay? I'm just going to call this y bar in this case. So now we take y bar and square it. So we take each of these values and square them. So that's where I'm going to need your calculator to help us out here. Okay? So we need to square all those values. So you do all those negative ones here. I'll do the positive ones.
And how much decimal places do you go over? 2?
Yeah, let's go over 2.
18.06. Oh, you're starting at,
okay, that's fine. 18.06. Okay, I'm going to start from the bottom. You go from the top. That way we can speed this up. 2. What'd you get?
0. Oh, oops. Oh, no. Oh.
It's okay. Try it again.
10.56.
10.56. Okay.
Mm,
1.56.
Yeah.
And then what is 0.25 squared?
0.06.
Okay. Now 0.06. Now all of these need to be added up together. So in other words, we have to find the sum of what I've labeled as y bar squared. So we add all these values together. That's going to be 1, 2, 6, 7, 8. 8 sixes is 4. And that's 10, 24. 2. Tell me what you get.
Is that 3? 3.06?
Mm-hmm. That is. think this is what you're going to get. But you just double check that, okay?
55.48.
Perfect. Then that value, we need to divide by the number that there are. So in other words, we take the sum of what I've labeled y bar squared and divide by the number of x values. So because there's 8, we divide this value by 8.
6.935.
6.935. And this is called the variance. So that's the standard deviation squared. Okay, when they give you that symbol. But the standard deviation would be the square root of that number. So what is the square root of that number there?
2.63.
2.63. Perfect. 2.63. So let's take this information. This is a standard deviation. And we knew the mean was 2.5. Assuming this is normally distributed, okay, let's kind of try to create our chart as quickly as we can here. So our mean was 7.25. Is that what we said? 7.25. That was our mean. One standard deviation, it's a little off there. One standard deviation was 2.63. Okay, so I want you to add 2.63 there. I'm going to put positive 1 standard deviation and negative 1 standard deviation.
That's what?
63. That should be
9.88.
8. Good. And if we subtracted 1, it would be 4.62. Great. Okay, so according to this, if it's right, 68% of all the numbers we found should fall under there. Okay, let's do another.
68.
That's how normally distributed information tends to work. Okay, and so we're going to test to see if we're close to that. Let's go another standard deviation up.
Oh.
And another one down, and then we'll do a third one. So give me a new value.
12.51.
Okay, and let's go up one more from that.
15.14.
15.14?
Yeah.
Good. Let's go down from 4.2. That's going to be 1.99.
1.99.
Okay, and then one more down from that would be a negative value. Yeah.
0.64.
0.64. Okay, good. So essentially 4.6 and 9.8. Let's see how many numbers fell between that. 4.6, well, no, 4 doesn't, but 6 does. 7 does, 8 does, and 9 does. So that's 1, 2, 3, 4 out of 8. That's about 50%. That's not bad. It's not exactly on 68, but it's pretty close from what we're going to get. We know that 95% should fall within 2 deviations, okay? Which means between 2 and 12. Well, if we go take a look, everything, 3, 4, everything fell between this, okay? So that was 100% of ours. Not bad, it's close to 95. And the reason this happens is because we have a pretty small sample size. What I mean by sample size is I only have 8 numbers to work with. If we were working with something like 30 or 40 numbers, then we probably would have gone closer to our targets of 68 being between these two, 95 being between these two, and we would have found the odd numbers outside of that range. Okay, but that gives you an idea of how to apply it to a normally distributed information. Okay.
So if I was to do that and then draw